In this video, we're going to talk about adding a display to our data acquisition system. Often this is really a handy thing to do because you want to be able to see your data real time, identify if there's any kind of problems, gives you some confidence that you're collecting good data before you walk off and leave the system. So it has a lot of uses. And historically, we often didn't add displays because they consumed a lot of power and they added extra cost. But with the advent of these new OLED displays, that's OLED or organic LED, we now have a very low cost and very low power system that we can use to add a display. So I've got some here on the down facing camera. You can see them here, they're quite small. I've got two different sizes here. This is a 128 by 32 or 128 pixels in the horizontal, 32 in the vertical. These other three are 128 by 64. And the ones on the left use an I2C interface. Okay, it's a 4-wire interface. All you need is power and ground and 2 more wires. And we use those on our sensors in the past. And our real-time clock also used the I2C interface. On the right-hand side, you see two SPI versions. That is, they use the SPI interface, and that's what we used for the SD card. Okay, so you have a choice whether to buy I2C or SPI, and you have some size variations. These three here were purchased on eBay, I believe for less than $8 a piece, so very inexpensive. They're not all created equal. I will point out here one thing. On these SPI versions, for example, you'll notice that one has 7 pins across the top, including something called chip select. It's very good to have chip select on an SPI device if possible. You can see what the back of it looks like. The other one does not, only has 6 pin and does not have the chip select. This makes it a little bit less flexible, and it uses a few more pins on a bigger data acquisition system because you can't share lines with other SPI devices. You can see that they look a little different, okay, on the back side. So beware when you're buying them to know what you're getting. And most cases, the ones with the chip select may cost a little bit more, but it's important if you're kind of short on digital pins to get that, so you can, for example, share lines on this with your SD card. If you don't need to worry about that, then you can get this one, which is lower cost. Today's example, we're going to use these two, the I2C version and the 6-pin SPI version. So I've got 2 of these wired up to an Arduino here. On the left hand side you see the I2C version, and on the right hand side you see the SPI version. Wiring's pretty straightforward. The I2C just uses the 2 I2C lines going to A5 and A4 for clock and data. And on this one, the SPI, we're using pins 6, 7, 8, and 9, okay, which we're actually going to define in the software itself to make it a little easier to use. I've also got a relative humidity and temperature chip on here just to give us something to read. This is a AM2302 or DHT22, super common, used in a lot of Arduino projects. And I'll show you how to wire that here in a little bit. Also requires a 10K resistor, and pretty easy to use. So let's look at software real quick. Now both of these systems require libraries. We're going to use 2 different ones. On the I2C, we're going to use this library, the Greenman SSD 1306 ASCII, and this number that you see here, or SSD 1306, stands for the driver for the OLED, the organic LED. So you'll see that a lot of the time, this 1306 in the name of different kinds of libraries and drivers, because that's associated with many of the OLEDs that are available. You can download it here. You actually have to go a little deeper in here to find it. You have to click here and go here, and here you finally see the H files and the CPP files. But I've actually already zipped all this up and put it on my website that you can download if you want to. The driver that we're going to use for the SPI interface is part of this Arduino tracker micro APRS system. You can see it's called SSD 1306_text. Now, when you look on a lot of people's websites, there's lots of libraries out there. The reason that I picked these two is because they're very low overhead. That is, they don't use a lot of memory. A lot of people are wanting to put graphics and fancy stuff on their LEDs. For most data acquisition, we just want to put text, that is letters and numbers. And so we can use much smaller libraries and avoid taking up a lot of memory in our Arduino. So that's why I picked these two and wanted to show you how to use them. So you need to download those files and import them into your libraries. So recall, you can go here to include library. Add zip library would allow you to suck those right in. I have already done that. If you look down here, here's the 1306 ASCII, which I'm using for the I2C, and the 1306_text that I'm using for the SPI. Like a lot of these folks that write these libraries, they provide nice examples. Let's go over here and get the I2C example real quick. The one I'm going to get is wire I2C 12864. You can see it right here. Okay, and at the top you see where we have some include files. We bring in the library itself plus the standard wire library. We define the I2C address, define the object, and then just in the setup, start the wire library, set up the display. You don't have to worry about this too much. You can just copy what they're using in the library in your own code. We clear the display. Then we actually take a time measurement, set the size of the text, and then write a couple of lines, and then actually measure how long it took it to write those lines. So you can see I actually have that running on the down facing camera right now. That's what just got through running, and it said it took it 29,000 microseconds, or about 29 milliseconds, to make that reading. You can see the text across the top. I don't know if you can see it very well. Kind of hard to see the down facing camera, but it's very clear and easy to read. And let me change something on it a little bit. For example, just to show you that it's working, let's put something in here like Arduino test. Okay, I'm going to go up here to my tools menu, make sure we're still connected, make sure, oops, I've got the wrong board selected. Need to make sure I get the right board. So now I've got the Uno, I've got the right port. Okay, now we're going to upload that. And I don't know if you can see it, but notice that this line changed. So we're communicating with that, and everything seems to be working just fine. So the I2C systems are a little bit easier to connect, but they're a little bit slower than SPI. So a lot of people will tend to lean toward SPI interfaces just because they're faster. I ran similar tests with the SPI. It was taking about half this amount of time to make that kind of a write here. So let's open up a different example on that one. I've actually already written a piece of code for that. So let's switch over to the other display now. Here you can see we have to pull in the SPI library. Then here's the SSD 1306 text library. Remember, we're using different libraries for the different interfaces. Here's where we define all our pins, okay? The data pin and the clock and the DC pin and the reset pin. We set up the system. This is just something that you can cut and paste. And but I could change these numbers to any pin, any digital pins. I can use whatever we want. That's why it's called soft SPI, not hard SPI. And then I'm initializing it, clearing the OLED, and doing a really similar thing that I did in the previous example where I wrote a couple of lines of text and then measured how long it takes. So I'm going to go up to Tools. We're still connected. So I should be able to upload this one now. And we should see some activity on the other display. And sure enough, we do. Now we can see we again wrote some things to the display. I don't know how well you can see it. And measured how long it took to write that stuff to the screen. And you can see it was significantly faster than the I2C. So both of them are very viable options. The I2C is a little bit easier to get working oftentimes, but if you've got a lot of other I2C devices on your data logger, sometimes you can have conflicts and it's slower. So I guess if I had to make a recommendation, I would lean toward the SPI versions. So let's continue moving on with this SPI version and see if we can connect this relative humidity chip to it and collect some data and display it on the screen.